So hello everybody, my name is Vittorio Romeo, I work at Bloomberg, and this is my talk on what I've learned in many years of teaching 11 and 14 at a large company. So before we begin, I'm going to give you a little bit of backstory of how this talk came to be and the book that I'm writing, which is the source for this talk and for the experiences I've had. So in 2016, I joined Bloomberg as a software engineer. And at that time, I was mainly working on infrastructure, large-scale systems, like our microservice architecture or our trading architectures. Always been kind of away from the finance stuff, mostly focused on the tech and infrastructure part of it. That's what I really love. And during my time at Bloomberg, I went through new hire training like anybody else who joins the company. And they taught us the basics of C++3. They got us to speed with what Bloomberg used at the time. And I noticed that despite it being 2017, and despite some mentions of 11 and 14 features here and there as part of the training course, there really wasn't any major focus on modern C++. So I found that as an opportunity to actually develop an in-house course and teach people 11 and 14, which I had been using before for my hobby projects and for my personal enjoyment. That went really well, and the course has been a success, and I'm still teaching it to this day at Bloomberg with many new people joining the company and wanting to learn more about modern C++. And it has also expanded to 17 nowadays, and that's became part of my job, basically. Now, during one of these sessions, my friend and coworker John Lagos attended the course. He was impressed by it. He didn't really have that much experience with modern C++ at the time. And he got really interested in the major new topics that I was discussing. And we got in touch and we started talking about how to make this even more impactful for the company and for the C++ community as a whole. So in 2018, C++ Now, which is one of my favorite conferences, and I really, really miss being, in Aspen, in the beautiful scenery, and meeting all my friends that I haven't seen in a while due to this pandemic. Like, we were talking and just chatting along, and we had this idea of kind of like writing a book that sort of encompasses all the experiences we had with modern C++, both from the teaching point of view, from the engineering point of view, at a company with thousands of engineers, and try to give people like a very focused guidance on what we think is safe in a large company and how to embrace these features if you have never really used them before, or if you haven't really gone in depth by analyzing what they actually mean when you introduce these features to a very diverse set of engineers. So since 2018, we've been writing a book. It is called Embracing Modern C++ Safely. And finally, I am proud to announce it will be out in December. And you'll have a taste of what it can be like in this talk and a few more talks that I'm going to advertise at the end of my one. So during 2018 and 2021, which was the time that I used to write the book alongside John and many other people, this was like this period of rediscovering 11 and 14. As I mentioned before, I had used modern C++ quite a lot for my personal projects. I do game development on the side, and I just like, in general, staying up to date, participating in standardization, and playing around with C++. It's a passion of mine. But just kind of like analyzing every feature from a different point of view and trying to really see what's the impact when you introduce these features in a large-scale company, getting experience from engineers, from code metrics and things like that. It really blew my mind how many things you can find to talk about, even about the simplest features like override or range-based for loop. There are a lot of little nuances that are really interesting and that I think will make the book a very interesting and useful read for pretty much everybody. So it was a period of rediscovering, and myself, I never claimed to be an expert in modern C++, but I had some experience, and I was still surprised how many things are there to learn in 2021 about a standard that was released 10 years ago. So that was a pretty awesome period of my life. And finally, 2021, we are going to release the book in December, but this is not an advertisement talk. I'm just putting it out there so that you know. But let's focus on the message I want to convey, which is, why are we talking about 11 and 14 in 2021? This slide should be updated. And how it can still surprise you today. Furthermore, I want to show you what it means to actually write C++ at scale when you are working with thousands of engineers with a very diverse background and skill set. And then I'm going to talk about this idea of safety of features that we developed as part of the book writing process, which we find really useful to actually teach C++ to the diverse audience in a way that's effective and doesn't waste anybody's time. And finally, at the end of the talk, we're going to have a case study of one of the features which I think are quite interesting, which is the extended friends declaration that was introduced in C++ 11. This is one of the features we claim it's unsafe, but like our meaning of unsafe is pretty specific. So I don't want to spoil anything, but stay until the end and I'm going to show you what is interesting about extended friend declarations. By the way, before I begin, I want to say I like to keep things interactive. So if you have any question, I'm going to be monitoring both the chat and the Q&A. And also, I don't know if you can unmute yourself, but if you can unmute yourself and you just want to, heckle and say anything, I like that. Let's keep this interactive and a discussion. So feel free to ask questions at any time. So why are we talking about 11 and 14 in 2021? There is something that isocpp.org does every year, which is really cool, and it's an annual survey. And basically what they do is send out the survey to as many developers as possible and try to advertise it as widely as possible in many communities. And they try to get some data regarding the use of C++. One of the questions they ask is, are you allowed to use modern standards either at work or for your personal projects? And we can see from this data that there has been a very steady increase in the adoption of 11.14 throughout the years. So in 2018, the situation wasn't that great. Fortunately, 11 was almost there, 83%, but C++ 14 was lagging behind. It was only 58%. Then, it starts growing. We get to 88 and 65. 2020, we get to 90% C++ 11 adoption and 74% of C++ 14 adoption. In 2021, which was the latest survey, we get an 87% 11 adoption and it's 76% 14 adoption. You can download this for free on the isocpp.org website if you're interested in seeing this data for yourself and also the other questions. But let's focus on this for a bit. So first of all, the sample size. What is the sample size of this survey? So it started with 3K people, which is quite good. But then over the course of the years, it kind of dwindled a bit. And in 2021, fortunately, we had at least 1.8K sample size, which is, somewhat representative if it's not great. But I think it's good enough for the purposes of getting some statistical data. And the results might seem good, right? But if you think about it, in 2018, around 20% of the people were not able to use C++ 11. And that's weird because that's 7 years after the standard was released. So it means that there was a huge subset of engineers, 20%, which is not small, that were not able to use 11 in 2018, 7 years after the release. And even in 2021, there are about 25% of the people that replied to the survey not able to use C++ 14. And if you see the trend for 17 and 20, it's pretty grim. Like the adoption of these standards is quite slow compared to, the speed in which they come out, at least for a large subset of people. And also my personal experience tells me that 11 is still quite a luxury in some places. For example, there are some companies like Bloomberg where we have a lot of very important and mission-critical software that has been written decades ago for legacy architectures. So, for example, there might be some very important stuff that has been written for Spark systems or IBM systems, and those platforms either don't have modern compilers or they are unmaintained. The conformance with modern standards is not great. So people just cannot use 11 and above on those architectures. And if you're one of those engineers, you're kind of stuck there, which is not great. And the other thing, which is, is not really something you should take. You should take it with a grain of salt, right? But when I go online on Reddit and other communities, I see a lot of people even on a random day be like, oh, I wish I could use C++ 11. Oh, I wish I could use C++ 14. Like every day I see somebody complaining about not being able to use these standards at work. It might be a vocal minority, because people that tend to complain are the ones that actually tend, to be more vocal. But it's still kind of puzzling that 10 years after 11 was released, there's still people that wish they could use 11. And I find it kind of sad. So a few questions or a few comments. Isn't the survey big on ICPP a bias in itself? the people there tend to use newer standards in general compared to the rest of the developers. That is a really good point. People that already visit isocpp.org and are trying to keep up to date are usually the people who try the new standards quickly. So that might be in itself, the real situation might be even worse than what we look at. Hardware made to the last 10 years, GCC Clang no longer supports these architectures. Yes, that's another issue, right? The compilers I was talking about for Spark and IBM, they are not Clang and GCC. They are their own, I don't know if they're proprietary from Sun and IBM, but they are not GCC or Clang. You might get GCC or Clang for them, but very old versions, so there's no way you can get the modern compilers there. The only chance is if somebody upgrades the proprietary compilers, but this is decade-old hardware, so it's very unlikely. The other thing is that time and experience matter. I know it's very cliche, but experience is the best teacher. And I was lucky that I started learning C++, I think in 2010. So I already had immediately exposure to modern C++. And since after learning and spending a few years experimenting with it, it has been my language of choice for my own projects and also for work since 2012. I've also seen that, especially in my company at Bloomberg, and probably even because of my impact and other people's impact trying to spread the love for modern C++, 11 and 14 have become more and more widely used in production. And we've been embracing these standards quite a lot and trying to push management and even people that really don't see the need for upgrading and showing them, look, this is good stuff. It's going to make our code safer and it's going to make us more productive. And at Bloomberg, I'm not only just developing software anymore, but since I had really successful run with my courses in 11 and 14, I've been doing that professionally as part of my job, as part of my daily tasks since 4 years. So I've been teaching to a plethora of different people with different experiences and skill levels for a long time, and I've learned a lot. I feel like that teaching is one of the best ways you can learn for yourself. The other problem is there are really good learning resources about 11 and 14 and even 17 nowadays, and I don't want to make it sound like they're bad resources, because they are not. But most of the resources I see in terms of books, videos, and articles, they tend to teach the features themselves, like the syntax, the usage, what can go wrong, how some basic examples, rather than the experience. So most of the resources I've seen, they fail to capture, those war stories where it's we used this in our company for 4 years and realized this minor detail that everybody misses because they usually just use them in a small project. But when you have 20K lines in a code base, these can actually be beneficial or a drawback. So this was one of the things that I really think is missing from the current learning resources. And in general, I've also seen that what looks good on paper might not work in the real world. And this is something that I experienced a lot, even as part of the standard committee. You're there sitting with the other people, you're reading a paper and you're like, wow, this looks amazing. I really want this in C++. And then if somebody just raises their hand and they're like, yeah, we had something similar in our company and we realized that while it looks good on paper, because of A, B, and C, this doesn't actually work on practice. So, sometimes things that are really fancy, they might cause problems. Case in point, I'm not going to cover it in this talk, but CTAD, class template argument deduction in 17, it does solve a lot of problems, but in practice also causes a lot of problems. And when you're reading the feature, you're just like, yeah, this seems just like an extension of function template argument deduction. It seems like a logical extension. Why shouldn't we have it? But then when you actually see the impact in the real world, you are like, okay, maybe we should have been a bit more careful. So there are things like that all over the place. And I think that the learning resources that we have nowadays don't really capture those feelings and experiences as well as they should. So another thing is that, as I mentioned, during my rediscovery period, I was surprised myself by 11 and 14 quite a lot. Maybe I just didn't learn it properly when I was learning it, but, I feel like even if you learn a lot, you'll still find these edge cases that might surprise you. Okay, so I have a question for you. What is the smallest change to the core language. So we're talking about the core language, not the library, that you can think of in C++11, like the most minimal thing, quality of life improvement that pops in your head. Let's see what people say. Okay, we say auto, move. I think those are very good quality of life changes, but they're definitely not small. Those have a lot going on for them. Think very small, like inconsequential changes. Syntactical changes. Let's see if somebody guesses it. Yes, so I see Dan and Ben mentioning this dreaded token, the double closing angle bracket or brace, whatever you want to call it. So if you don't know about this, before C++11, if you had a nested template, like a stud vector of a stud complex of int, then when you were syntactically writing the closing angle brackets for the nested template, you had to put a space between the two closing angle brackets. And the reason was that the C++03 standard always required two closing angle brackets to be parsed as a bit shift operator, even though they were, where a declaration should be. So in 11, they made the parser a bit smarter, and it says, if you are obviously opening and closing templates, then you can avoid putting the space there, and I'm going to figure out that what you want to do is close the nested template, not bit shift or stream something. So even this small inconsequential change can have an impact. So did you know that actually this change can make a valid C++ program ill-formed in 11 and above? Or even the same exact program, when compiled in 03 mode and in 11 mode, will compile and run, but it will suddenly change its behavior because of this syntactical change. So here's an example, very basic, but if I have this template struct called paddedbuffer, which takes a template parameter of type integer power of 2, it might be some sort of buffer aligned to some hardware-specific boundaries, and I create an object called small buffer of type paddedbuffer 256 double shift to the right 4, then this code will be valid prior to C++03, including C++03, but it is ill-formed since 11, because the compiler now doesn't understand whether you are trying to close padded buffer with 256 and then comparing that to 4, or it just gets confused while parsing. So there is an easy fix, of course, which is wrapping the right shift expression in parentheses, and now you're making it clear that that thing should be an integral result, and it should be passed as the argument of the class template. The other example is this one. It's a program that's valid in both 03 and 11, but with completely different meaning. If you run this program, if you compile this program in 03 and then run it, it will return 100. If you run this program in 11 mode, it will return 0. I'm not really going to spend so much time on this because these are corner cases. These are not things that happen in practice. The point I'm just trying to make is, if for such a small change, just a syntactical quality of life improvement to just make you able to avoid a space in a place that looks just ugly, because that's the reason why we had this improvement. It just looked ugly. If such a small change can have these ramifications, even though they're corner cases and you're very unlikely to see this in practice, imagine what the largest changes can do to your code bases, can do to your understanding of C++. So I'm not trying to tell you that this feature is bad or that you have to be careful about this stuff because it's super rare, but I'm trying to show you with an hyperbole that even the smallest change can lead to unexpected results, butterfly effect. So some questions. Do you talk about such corner cases when you teach 11 and 14 or leave it for deeper talks? That's a good question. I tend not to talk about this stuff to beginners because I want to give them the tools that they need to be effective at their job. If I'm giving something like a class at a conference or maybe a deeper talk or a talk like this one, then I like to go into tangents and have a bit more of a discussion. But when I'm doing this professionally, I try to keep it, keep these things on the side. And if people are interested, we can have a chat later while we're having lunch and things like that, just to bond a bit. But I tend to not teach this if there's no need to. Are easy fixes like this available by Clang-Tidy? Yes. So I'm sure that compilers, even without Clang-Tidy, would warn on this behavior. They would tell you, I don't know what version, but there are up to a certain version, they will tell you, hey, look, if you compile this, 3 and 11, it will have a different meaning. So I suggest you put parentheses there. So sometimes, like in this case, you can rely on compile diagnostics, but that's not always the case. So it's not a foolproof way of being confident about the correctness of your code. Yeah, so that's a corner case, right? It's just to prove a point. It's not something I want you to focus on. But do you know about attributes that can actually make your code ill-formed NDR? And ill-formed NDR means that your code will be completely broken undefined behavior, and the compiler is not required to diagnose it. Actually, it's going to be very hard for the compiler to diagnose it. And attributes, which seem like just this extra information you add for tools and maybe for diagnostics, they can actually make your program completely broken. Extern template. I was guilty of this. I was convinced that extern template was the main reason for extern template was as a tool to improve compilation time and isolate some templates into CPP files to avoid duplicate instantiations. But sometimes even if you use extern template the way you think it should be used, it might not improve compilation time or even slow it down and not improve code size at all. There are some weird interactions, and extern template just works in specific cases. And this was very surprising. Myers-Singletons. We love Myers-Singletons. Super easy to create. They save us a lot of pain with synchronizing initialization and deinitialization of an object. But even if you do everything right, you can still get into UB because of destruction order issues. And that happens quite a lot in practice if you have global objects like loggers that rely on another global object like a file watch and stuff like that. So even something that seems, hey, a super safe way of creating a singleton actually hides some danger. Rostering literals. I'm sure pretty much everybody has used these to embed some piece of XML or JSON or Python inside your C++ code. But do you really know what happens to the white space you encode within rostering literals? What happens if you use encoding for your source file? Does that encoding affect the white space? What happens to tabs? What happens to carriage, feed, and return on Windows versus Linux? These things can matter because the value of your literal can change depending on the platform you compile on. So what I'm trying to say is that like almost every feature, even the most innocent ones that you just think, oh, this is just going to make my code nicer, they have a dark side. And I rarely see this stuff being discussed. And this is something we try to focus on a lot on our book. Just look at this feature and see what can go wrong. Because if you have a company when there's like thousands of engineers and you teach people this feature, they will use it. And over 1,000 engineers, at least one of them is going to end up in one of these dark corners. And the consequences might be really, really painful. And we want to prepare them for that. Okay, I have to clarify myself. We love Myers-Singleton. Speak for yourself, there's still Singleton. Yes, I love Myers-Singletons in the realm of singletons, but I hate singletons. So please don't quote me. Don't say that I love singletons because that's not what I said. So what about modern C++ at scale? This is something that I personally care a lot about because I teach in my daily job. And as I mentioned, there's a huge diversity of skill and seniority, which I think is great because it allows people to like have very varied point of views and think about solving problems in different ways. But it also makes it really hard for me to decide what features to prioritize, avoid, and what kind of system to use to make sure everybody gets the information they need to get. And the other thing that's often not really talked about is the impact of style guides. Google as a style guide, Bloomberg as a style guide. People just take them for granted, right? They're like, yeah, the company uses the style guide. I'm just going to follow it because I'm part of the company. I like consistency. But who writes the style guide? And why did they pick those particular rules? Like, what is the input to somebody running a style guide? And this is something also we try to solve with our book. So it's my experience regarding diversity. In the classes I've taught at Bloomberg and even at conferences like CppCon, the age range of people was very, very large. I've seen people as young as 21 years old, even younger at CppCon. I have students come into my classes, and I've taught to people even older than 70. Now, there is nothing wrong with, being older or younger, but it means that, if you're older, you're gonna have a lot of experience potentially with older languages and other technologies and things that don't exist anymore. You're gonna have a different way of looking at things. If you're younger, you might not have that experience, but maybe you are a little bit more excited about new things, about learning the modern way of doing things. Then there's Spiral C++ experience. I've talked to people that have played around with C++ in their spare time, and I've talked to people that have no idea what C++ is. Other languages. If I am teaching, lambdas, and my audience is a group of Haskell developers, then they will understand lambdas without any problem. If my audience is a bunch of people that have just, C university experience, they might not be accustomed to the idea of functional programming and higher order functions in the same way. Interest is also another thing. Like, there's some people that just want to get the information they need to get the job done and go home. And I think there's nothing wrong with that, right? Because eventually we need to realize people have different priorities. Maybe people just want to do this as a job. So they don't really have that kind of like drive to know about modern C++. You have to kind of like sell it to them that this thing is going to make them more effective at their job. And there's other people that are like, wow, modern C++ is so cool. We have auto, we have lambdas. I want to use all of this stuff. So on the other spectrum, there's people that tend to overuse the features because they're excited about them. How do you curb that interest, and how do you get the people that are not interested? That's also an interesting problem. And there's also people that are going to end up doing application development work and people that are going to end up on library teams. And there is a lot of overlap, but there's things that I would like application people to never touch that library people should definitely know how to use. So there's also that kind of problem there. Teaching C++ with this huge diversity range is a massive headache, to be honest. And you need to try to find a subset of things to teach that work for everybody and kind of like maximize the time that's being spent in a way that's effective. So, few questions. How is the audience of your classes formed? Do people sign up to learn from you within the company, or does it come from upper management that they want to attend? Because I think that can really change the motivation now to tackle some stuff. So yes, so I think this is a thing we can work on. So right now, the way it works is that we advertise the classes kind of like globally to engineering. We have communication systems to do that, and pretty much anybody can sign up. But if we had a class of new hires coming in the week before, we give priority to those new hires that just learned C++ for free to join into the 11 and 14 course. So there is a bit of manual intervention there. And also, we have had multiple cases where managers are teams that just started migrating to 11 and 14, and they were like, look, we're migrating to these new standards. We like the whole team to be taught about it. And we organize like ad hoc sessions. So I agree with you. I cannot give you a straight answer because it's complicated, and I really never thought about the implications of this. But it's interesting. Like, if you want to share some of your experiences and maybe advise on this, I would be happy to talk to you later. Because I'm sure that the way we advertise promotes bias, right? Maybe some people are never going to be, the outreach is never going to be there for people that don't monitor those channels or don't have the interest I just mentioned. Do you ensure somehow that the one engineer out of 1,000 gets help once they get into a dark corner, which was not covered in a class? Good question, and the answer is absolutely yes. One of the things I teach is something that I feel like everybody should learn, which is how to ask for help and where to ask for help. So as part of my courses, I make it a very important point to advertise internal and external channels, both inside and outside the company, where you can get help with modern C++. Even like C++ Slack channels or Stack Overflow or Reddit, or our internal channel that we monitor with our chats. And also, one of the other things I teach is online tools. You'd be surprised how many people don't know about cppinsights.io, which is one of the tools where you write modern C++ on the left-hand side, and it kind of like demystifies and desugars the code on the right-hand side. It shows you what is exactly happening. And like knowing to use those tools and knowing to ask for help, and for example, just providing, a Godbolt Compiler Explorer link to somebody so that they can play around with it, makes it so much easier for people to help you out. And also, one thing that I've noticed is when I'm trying to ask for help because I'm stuck with something and I'm trying to make a minimal example to share with people, I usually find a solution while I'm making the minimal example. So knowing that those tools exist and that those media for for communication are there, I think is a great thing to teach, and one of the things I try to focus on so that people actually know how and where to get help. Okay, style guides. I'm gonna speed up a bit. I'm not gonna spend too much time on the boring stuff, but like one of the things that we want to do with the book, Embracing Modern C++ Safely, is have this book be an input to a style guide. Like I've seen a lot of rules of style guides, even in my company, being there in place just because they were there for 10 years. Because people used to do a thing one way, it's being done that way, and that's one rule of the style guide. Or I've seen in other companies, talking to other people, that some of these rules come from personal opinion. The guy at the top decided, hey, I don't like this way of doing things, I prefer this way of doing things, so that's going to be the style of the company. So one of the things we're trying to solve with Embracing Modern C++ Safely is having an objective analysis of all the features, including their pitfalls. So if I want to write a style guide for my company or update a style guide for my company, I can objectively look at the book and say, okay, this feature is mostly good. There is this pitfall here, but it's not something we want to run into very frequently. So this should be something that we encourage or something like that. So this is something we're trying to make with our book. I think about style guides different from coding standards. Do you view them as one for the purposes of this conversation? Yes, I'm talking about the same thing. Coding standards mostly. Maybe the terminology I'm using is not the most accurate. Thank you for pointing that out. What I'm trying to say is like coding standards as well. Things like you cannot use this feature or you have to do this way. If you consider that style or standard, I'm talking about the same thing, yes. Okay, let's get to the more interesting bit, safety of a feature. So one of the things we do in the book and also when I teach is that we define a level of safety for features. Of course, if you know how to use a feature, you know that how to use it safely, right? Every C++ feature is safe when you use it correctly. But the thing we're trying to capture with the safety metric that we use is what is the likelihood that you're going to use something correctly? Does the feature have any attractive nuisance, which is a term that John uses a lot, which I really like, and it means this feature tends to point you or drive you towards a certain way of writing code, which ends up being a problem. So that's why it's attractive, why it's a nuisance, because it kind of is natural to go there, but when you go there, it's bad. And we have some examples of that. What are the advantages of using this feature compared to its risks? If this feature has a very, very dangerous risk, but it brings a lot of advantages, is it safe or unsafe? How do we measure that? And then, is it worth teaching this feature to a new hire? Should a new hire know about extern template? I don't think so. But should an experienced hire that works on libraries that are heavily templatized know about that? I think so. So this is also something that gets into the safety metric. So from our book, this is what we say. We say the degree of safety of a given feature is the relative likelihood that widespread use of that feature will have positive impact and no adverse effect on a large software company's code base. So we are looking at this from the perspective of a larger company, of a large code base. So for your tiny, hobby projects, might not apply, but the information there is still going to be useful. It is not an exact science. It relies on teaching and user experience. So as much as we try to be objective, there's always going to be some subjectivity there. But we still think it's a very useful metric to decide what to teach or to focus on. And I've noticed that in my teaching career, that has been mostly true. It's really helpful for me to know what people will find most useful and less dangerous. We have 3 safety levels. We have a safe level, which says that this feature adds considerable value. It is easy to use and hard to misuse. Therefore, ubiquitous adoption of such features is productive. We should encourage people to use these features. Conditionally safe. These add considerable value, so they can really solve problems in a very elegant and natural way, but they are prone to misuse. So we want people to use this, but they need to know about the problems and the pitfalls. Like, we cannot just tell people, hey, just use this everywhere is nice. You need to know how things can go wrong. And then unsafe. We are not saying that unsafe features are useless. We're saying that unsafe feature provide a value only in the hands of an expert and are very prone to misuse. So I wouldn't want to teach this as a general 11 and 14 course, but they are great for self-contained, smaller courses of tech talks. So I could have a 1-hour tech talk on external template, how to use it, when to use it, and when not to do so, because there's a lot to talk about. I wouldn't want to teach that to a beginner, but there are people that might have really, really good uses for them. Okay, I'm going to give you some examples. Override for us is the poster child of a safe feature. You know, if you've never seen override, you basically stick it at the end after the parameter list of a function declaration to ensure that this function does indeed override a function with the same signature in the base class. And you know, there are some cases where that might not happen. You know, you could have a typo. Instead of saying connect, you forget the T and you say connect, and then, you know, you're just not overriding silently. Or the signature changes. Somebody goes in the base class, messes up with the signature, and forgets to update the derived class. Override prevents all these bugs because if you are not actually overriding what you think you are, the code will not compile. And as an added benefit, it is documentation because I'm reading this class and I know immediately that this is a virtual function. So there are no real technical downsides. This is something that I want to teach immediately and tell everybody, just use this thing as much as you can because it's good. You cannot really screw up with this feature. However, even override, which has no technical downsides, has a downside. And we call this like a people downside, an engineering downside. If you get used to override being everywhere in a code base, and if your brain just, you know, gets to the idea that whenever you see override, it's overriding, whenever you don't see it, it's not overriding, then for those cases where somebody might override something but forgets to put override there, then you might be tricked into thinking that it's not a virtual function and you might do something that relies on that knowledge. So if you have over-reliance without enforcement of the override keyword, then that might be a pitfall. So one of the things we do is encourage people use override, but make sure that you have static analysis to enforce it. So if you have a new code base, make sure that you have the right compiler flags or clang tidy flags that tell you, hey, this should be override. Because if you start using it without those, and sometimes you forget about it, then you might start relying on it and wrongly assuming that something is not being overridden. Conditionally safe feature, range-based for loops. So I think these are great until they aren't. Look at this code on the screen. Context is, this is code from one of my open source projects. It's called Open Hexagon. It's a game I've been working on as a side project for a while. And I basically implemented this kind of system where you can rebind your keys if you don't like the default keys. And, you know, you can have multiple combinations of keys. I call these combos. So you can say, if to move right, I want to press Control and F together, you know, weird stuff. Some people have weird desires in their keyboard layouts. And I had this code over here where I basically iterate over all the combinations that I get from a function call with some getter on a bind ID, which represents the action in the game. And trigger getter is this function, this type over here, which has a get combos, which returns a vector by value. And you can assume that this function over here, keyboard trigger getters of bind ID, returns a trigger getter by value. So I want to ask you, do you think this code is correct? Okay, so I'm glad to see that people think this is fine. So I have two people saying this is good. Somebody says that the code is wrong. Okay, this is a very interesting code snippet because this code is actually totally fine. We don't have any lifetime issue. And the reason why we don't have any lifetime issue is because this thing is returning by value, this thing is returning by value. So we have a PR value. The PR value gets bound to the range invisible reference that the range-based for loop generates. Since it's a PR value, it's going to get lifetime extended. So no problem there. The vector will be fine for the duration of this loop. No problem at all. This code was fine. Game was released. Everybody was happy. Then I implemented an optimization. I figured out that there's no need to recalculate all the combos every time. I can just do that once when the configuration file of the game is loaded or changed and store those combos in a cached vector. So I changed trigger getter to store the combos in this cached combo vector, and I changed the signature of get combos to return a reference. Simple, right? I avoid recomputing it, it returns a reference, and now everything is broken without me knowing, because this piece of code was in a different place in the source code and it was working fine. So I had no idea that by implementing this, I would have broken this piece of code. And now the reason why it is broken after I implement this optimization is because get combos will return a reference, and the reference is going to be bound to the invisible range forwarding reference inside the range-based for loop code that's been generated. It will not lifetime extend. This thing will go out of scope, and the reference will be invalid. So there's a question, how fast did it broke? And the answer, sadly, is not fast, because I didn't realize it was broken until I tried this on Linux. So for some reason on Windows, it was doing fine. Then I recompiled this on Linux, I think with Clang, and on Windows I was using GCC. So it might have been the compiler difference as well. And then on Clang, it started, like the replay system started doing weird things. And I was like, what's going on? And I looked at the replay code and I was like, I didn't change anything, so why is it broken? And this was one of the cases that's quite rare where UB in one place actually affects another place. And then I used address sanitizer and I figured out, oh, I made that mistake again. I relied on Rangebased for loop and I didn't realize that I was doing something wrong. So it did break only on a platform, only with a certain compiler, but I think it would be broken anyway. It was UB, so you're never sure. Yeah, I mean, in the end, I don't remember what I did. I think I just took this line out and copied it outside, and it was fine. So yeah, range-based for loops are quite a good tool, but you need to be aware of where they can go wrong. So you don't need additional training. When I teach override, I'm not going to tell people about the over-reliance and things like that. I'm just going to tell them use override is good and use static analysis to ensure you use it. That's it. I don't want to bother them, right? I want to give them a full sense of security that C++ sometimes can be a nice green garden with flowers and it's beautiful and it smells great, right? But when I teach range-based for loop, I have to tell them these can go really badly and you need to be aware about it, because these bugs are more common than I'd like to admit. It's really easy to get into this issue. And I had this slide that I changed like literally 15 minutes ago, 15 minutes before starting the talk, because there was this paper from Yasudis and other people that was called Fix the Range-Based For Loop that was proposed for standardization. They wanted to change the way the range-based for loop compiles under the hood to be something a little bit safer that avoids this mistake. However, despite like a massive support from the community and a large part of the committee, this was rejected in 2021 September, so last month, by the standards committee, because they wanted to pursue a more general solution that also works in other cases. Now, I wasn't there. I was in favor of this paper, but I didn't really hear the counter arguments. Maybe they were valid. However, it seems to me this is one of the cases where perfect is the enemy of the good. You know, we had a nice way of potentially removing a class of bugs that people make and kind of like, you know, can lead C++ to a very bad reputation. And it got rejected because we want to pursue something a little bit more formalized and complete. But is it really worth it, right? And this argument for me is the same with reflection. Like, pretty much 80% of the use cases for reflection is enum names. So would it be that bad if we had, you know, a function to just reflect on enums and names until we get a full solution for reflection? Like, people want that. Couldn't this be the same? Couldn't we have a fix for range-based for loop, which is like the most common tool, and then eventually have a more general solution later? So I don't know. I don't want to turn this into a more philosophical talk about that, but unfortunately, I will still have to teach this pitfall, and I will still have to tell people that they cannot be sleeping soundly at night if they wrote a range-based for loop in their code that involves references and things like that. Okay, so some questions. Where would you put auto on your safety levels? What if we remember proxy objects from vector bool? There's problems with that. Yeah, so auto is conditionally safe for us. It's one of the tools that's really useful, can really help with readability, can really destroy readability, but it also has some technical issues, like you mentioned, for example, proxy objects don't work well with auto. So it's something that we teach, but we also teach the pitfalls, and we want people to be aware of them. So mostly with conditionally safe features, we also have exercises. So, after you teach something, even if it's just a slide where I ask a question, that's important for me to test their understanding. I'm like, okay, I've taught you about auto. Look at this slide. Is this fine? It's using auto. Is it doing the right thing? Like, I want people their brains to start thinking about, okay, auto, I need to think about it. I need to see what's happening to be sure that it's okay. So that's conditionally safe. Can you name an example of an 11.14 feature whose safety level would change depending on the code base? Like the tooling setup would promote it from safe to conditionally safe, etc. So it's an interesting thought. I don't think we definitely don't promote or demote depending on the type of code base and tooling. It's just the way we chose to do it, right? But we definitely have a lot of features where we mention you should use this with tooling. You should use this with static analysis. Override is one of them, right? I mentioned at the beginning, we want people to use override with at least the flags that tell you this could have override on it. It doesn't promote a safety level on anything, but the fact that a feature, let's say if a feature has a lot of places where we say this should use static analysis, this should use static analysis, that's definitely something that we consider in the categorization to make it a little bit less safe than it should be, right? If you need to rely on external tools and build settings and things like that, then it definitely affects the rating to go towards the unsafe side a bit, because you need that extra preparation and you need to know that you need those tools. I don't have a specific feature in mind. I'm gonna leave your question up. At the end, I have a slide with all the features, and we can take a look at that. Opinion on CTAD, I'll keep that for the end as well. I don't know how much time I have, but if you put that in the Q&A, I will remember so we can discuss that at the end if we have time. Okay, example of unsafe feature, Decaltype auto. So this is something that I used to teach in my course alongside auto and Decaltype. I'm like, okay, I'm teaching auto, good. Teaching Decaltype, good. So I'm just going to teach Decaltype auto. And this is something that one of the things that you do naturally, because it's just like, yeah, it's just an extension of the other two features. But then I thought about it and I was like, when is this thing useful? And there are some important use cases for Decaltype auto, but they're very niche. And there are cases where it doesn't make sense at all. Like Decaltype auto is only useful as a return type when you have heavily templatized code that relies on higher order functions and you don't know what they might return. That's pretty much it. And if you have this function log and call, you take some other function object f, you log, and then you return what this thing is invoking, then yes, you want Decaltype auto, or at least a Decaltype train return type with the whole expression, because you don't know if this is going to return an object or a reference. So it's the right tool to use. But the actual results of teaching Decaltype auto right after auto and Decaltype were not great, because people look at it and say, so this is a more flexible auto. It can be either object or a reference, so I don't have to think. I just put Decaltype auto and it does the right thing, right? Or some people thought, if it does everything that auto does and more, why not just use it instead of auto, right? It's a superset. Or if it's more flexible, if I'm not sure whether I want one or the other, why not just use that and let the compiler decide for me? So this is not what I want. And one of the reasons is that when you use something that is flexible, you're making your code more complicated. There is a talk by Kate Gregory, which I think is a fantastic speaker, and she says that simplicity is the most limited tool that you can use to get the job done. I think, if I'm not misquoting her, maybe something different, but I really like that quote, and it stuck with me. If you want something to be simple, use the most limited tool for the job. Like, you wouldn't use a void star if you could use an int star, right? Why use something more flexible? If you use something more flexible, then people reading your code are going to be like, okay, he's using void star here, so that means that int star wasn't enough and there must be a reason why he's using void star. Same thing, he's using Decaltype auto here, so it means that auto wasn't enough or autoref wasn't enough, so there must be a reason here. So using exceedingly complicated tools or flexible tools is detrimental. Another example, I think this was actually what Kate Gregory was saying. When you can use both emplace back and push back and have the same result in terms of performance, she says you should use pushback. And that's also a very good idea because it's the most limited tool for the job. Even though emplace back would do the same thing, it's overly flexible. Like, why would you use emplace back when you have a simpler tool that does the job and has less surface area that you have to think about? And I think that's what simplicity actually is. Knowing what the most limited tool to solve the problem is and don't using other tools. So, Decaltype auto. To know exactly when this is the right tool, you need to know, you need to have a solid grasp on type inference and value categories, which beginners will not have if they just learned about auto. You need to be somewhat experienced with Decaltype and auto, which again, a slide doesn't make you experienced. A month of using it might. And also metaprogramming experience, because this thing is often used in conjunction, as I mentioned, with Spine or forwarding references that take callable objects and stuff like that. So it's pretty complicated. I've asked this to so many people, and I'm asking it to all of you. Find me a valid use case for Decaltype auto as a variable. And by valid use case, I mean a piece of code where you have a variable declared with Decaltype auto, and I look at it and I say, yes, that's exactly how I would write it. There is no way I can make it simpler. Because all the use cases that I've seen for Decaltype auto in variable positions are just code smells. They could either use auto or autoref, or you could either rewrite it to not use Decaltype auto in the first place. So if you really have an example of Decaltype auto in variable position where Decaltype auto is the right tool, please send it to me. I've been looking for this for so long and I couldn't find it. The only real use cases for me are Decaltype auto as a return type placeholder. And even those use cases, they have to be compared against a train return type where you copy paste, the final return expression, because that does the same thing and it's also Spine friendly. So when you use Decaltype auto, you also lose Spine friendliness, which is another thing I don't really want to explain to beginners, right? And it's far from trivial. I'm not saying it's a bad feature. I'm just saying it's complicated. It has a lot of nuance. So for me, it's unsafe. And when it's unsafe, it means it has value, but I'd rather teach it on a separate course, maybe 1 hour, 2-hour course on metaprogramming with Spine, high-order functions, Decaltype auto. That's the place for this feature. It's not in a beginner course. And this is self-criticism because I put it on a beginner course as I was following the, auto, Decaltype auto. That's a bad thing that I've done, and I'm glad I realized that. Okay. So more examples, safe, we have attributes, null pointers, static assert, digit separators. Conditionally safe, we have auto, const expr, r by references. Unsafe, we have the carries dependency attribute, final, inline namespace, weird stuff. Final might be surprising to some. If we have some time at the end, we can discuss that. Fortunately, I want to say that most features end up being safe or conditionally unsafe. So in 11 and 14, we identified only 7 for 11 and 2 for 14. And if you see the total, it's reassuring, right? There are some dark corners and some unsafe features, but most of them are relatively good. So the book is going to cover 11 and 14, but we are already in progress in doing some research for 17. 17 has been around at our company for a few years now, so we are glad to have some data that's actually real world data that we can use. 20, I think, is going to take a long time because 20 is one of those bigger standards. We have a lot of major features, coroutines, modules. It's going to be tricky, and I feel like I would be comfortable talking about 20 only if I had several years of experience actually using it. That's what I care about. I care about teaching things that I use. Like, I don't want to read the papers and teach them. That's not teaching. That's just regurgitating the papers in some other format. I want to use it for a few years and then teach them. That's how I feel comfortable with my expertise. Yeah, so don't want to repeat myself, But teach safe features early and quickly. Trust your students. They will figure them out. There's no need for hand-holding. Conditionally safe features, teach them by building on top of the safe knowledge. They require more time and example. You have to show how they can backfire. You cannot trust your students to figure that out on their own. And have exercises or even interactive slides. It doesn't have to be complicated. Just put a slide on the screen with some code and make them think. And ask them, is this use of this feature safe or not? What can go wrong? This is how you get those ideas in their head about the pitfalls of these features. And then leave a subset of unsafe features for self-contained smaller courses. For example, I want to teach inline namespaces. I'm going to pick a use case and I'm going to be like, I'm going to teach you how to do library API and API versioning with inline namespaces and all the things that can go wrong. This is the way I would strongly recommend you teach modern C++ at your company, to your students, to your friends, or to whoever is interested. Okay, so I think we have 30 more minutes. Is that right? So I'm going to take a look at this case study. And this case study is going to be about one of the features we claim is unsafe, which is extended friend declarations. And I'm going to, guide you through some examples and see if we're going to agree about this categorization. Okay, so let's begin with the basics. So prior to C++11, whenever you wanted to introduce friendship between two types, the way you did that is by having a friend declaration as part of the definition of the class that you wanted the private members of to be accessible from the friend. And those friend declarations required something called an elaborated type specifier. So this thing is a syntactical entity that looks like the following. Either a class, struct, or union, then a space, and then an identifier. So you could say you might have a struct s forward declaration, a struct example, and inside example, you might have said friend class s, friend class non-existent. These would both be valid, and these would be friend declarations. Now you can already see the problem here, right? I can have a friend with s, and s is something that exists, but I can also have a friend class non-existent, and this is both a class declaration and a friendship declaration. So it allows you to create friend declarations that do not exist, to types that do not exist. So people say it's a 1 hour presentation. So if it's a 1 hour presentation, we can jump to the end. Can I get a confirmation from track host, please? And we can discuss this in a separate format. Yeah, so it's a 1 hour session. Sorry about the misunderstanding. So I will link you the slides so you'll be able to see this on your own. And you can find me on Discord. So if you want to discuss this on Discord, I'll be happy to do so. I can even present it on Discord if that's something that people would like. So that's totally fine. But in terms of conclusions, the book is coming out this year, December 2021. So it's finally done. It's been a lot of pain, but a lot of very hard and good work. All the people you see on this slide have contributed a lot. And there's also other people that are not on this slide who have contributed. So thank you to everybody. I think it's going to be great. We have, the expertise, combined expertise of a lot of people that have been in the standards committee and in the industry for many, many years. You can bookmark this website or follow me on Twitter for updates. And there are some related talks that you can take a look at. There are some talks regarding specific features that we extracted from the book. And these go really in depth into showing you the kind of analysis we did and how weird things can get and how interesting things can get. So I strongly recommend this. We have one on UDLs by Pablo, one on variants and the destruction of variants, which is a specific topic on by Andrei Alexandrescu. Alistair and Nina are going to talk about PODs. And then John Lake is going to talk about no accept. So pretty interesting stuff. Check them out. They're going to be on Tuesday and Thursday. And finally, thank you so much for coming. I hope I catch you on Discord for more information and for more discussion. And this is the final slide that contains all our categorization. So take a look at it. Let me know if you have any questions. And we will just discuss on Discord and continue the discussion going. I think there's a lot that we can talk about still.